Welcome to the final video of this three-part series on the Pioneer SX-990. Thank you for hanging in there to the end. Let's quickly go over what we have finished so far and what we have remaining to complete. The shapes in green have been completed, and the shapes in yellow are boards that we will work on in this video. This current image is the top-down view of the receiver's components. In the first two videos, we worked on the main amplifier board, the power supply, the front controls, and we replaced all of the lamps. The FM IF board, the FM Multiplex board, the AM tuner board, the control amp board, and the head amp boards will be the focus of this video. Please note that I will not be showing video of me replacing components on all of those boards, since it would be boring and it is repetitive and there is nothing to learn or gain from seeing the same thing over and over again. That said, let's get started with the FM IF board. Electronics can be deadly. My videos are for entertainment purposes only. If you attempt anything you see in my videos, you are doing so at your own risk.
Well, I wasn't going to replace or blindly replace the caps on the FM IF board here, but I started just checking a few of them and they are pretty bad. For example, this one here is I don't know if you can see that. That's a 4.7 microfarad 16 volt. And let's check that. Just check it with a meter. We won't bother with the ESR right now. 16 microfarads. So almost 4 times, 3.5 times what it should be. What I'm going to do is I'm just going to go through and replace the electrolytics on here, and I think there were only 2 or 3 maybe, so we'll just do that real quick and come back. Alright, let's check this one real quick, just for grins. And this one comes in at 8.5. Still, twice what it should be. Those are not good. I think these are both 4.7. Yeah, 4.7. Let's see what I've got. I hear a couple of replacements. These are 50 volt 4.7 microfarads, and they are tiny. The 16 volts were tiny already, but these new 50 volt ones are just ridiculously small. All right, let's get this one on the end out of there. Okay. This is a 1 microfarad at 25 volts. So let's see how this one performs. I bet it's pretty bad. 0.09 nanofarads? What? That's a 1 microfarad. Wow. That can't be right. Let's try something else. I plugged it into this M tester and I got 35 picofarads. That's comical. 1 microfarad all the way down to 35 picofarads. Let's run it through the DE5000. See what pops up. There we have it. $790. See, that seems better. 797 nanofarads. So you're 20-ish% off at 1 kilohertz. 19 ohms of ESR. Probably not great. So yeah, let's replace that one too. All right, let's see if I can get these in here correctly. We're gonna go the opposite direction that we took them out. This is the resistor lead that's right next to it. Okay. It's tough soldering around a tripod. Next. This is ground. Well, no, I'm sorry. This is where it was grounded before. So I'm just going to put it right back where it was. You know what? I'm going to do this a little differently than I had it before. I'm going to try to put it in the middle. Stay right there. Might need to reflow some of these joints. I'll have to take a look at them. All right, last one on this side of the board. And it goes like this. Yep. Go that way and go that way. That'll be good. Did I just find it? There it is. Okay. I think we're good on that. Let's just check it and make sure there's nothing else on this board to replace. Oh, there's one more down here. I gotta figure out how to get to that one. One more down here on this side, hanging out over here. We'll pull him out. Looks like another 4.7. Can't tell from here. Oh, looks like 1 microfarad. Ah, let's pull it out and look. All right, I think we're looking for this spot and this spot. Let's make it happen. Nope. Okay. That's one side. Yeah, okay, so that's one side. Now here's the other one. Okay. All right, let's take that one out. Ooh, this one's beat. Okay, it's 1 microfarad, 50 volts. Or not 50 volts, 5 volts. No. I can't tell. Yeah, it's probably 50. It's weird how it's spaced out like that. Okay, so that's 50 volts, 5 volts, 1 microfarad. I can't tell. I'm pretty sure it's 50 volts. So that's what's going back in there is 1 microfarad. Let's grab another one of those. Okay, this is not marked on the board, and I wasn't paying attention when I pulled it out like I should have been. But I did test around, and I know that the lead on the left is the ground. So I'm going to put this in like this. And I did check the other capacitor. The other capacitor is not bipolar. It is polarized, so we're doing what we're supposed to. Let's get that one in there. I'm blind as a bat, and I'm trying to look at this board from about 1.5 feet away behind the camera. It's tough to do. I don't know. I'm not complaining, though. Okay. I think that's the last one on this board. The last electrolytic. I'm going to make the assumption that the rest of the capacitors, film caps, micro cap, not micro cap, film caps, and dang it, what's this green one called? It's a film cap and the ceramic caps are okay. So we'll just go with that because it was working great before. All right, I'm generally not a fan of putting screws back in something until it's been tested, but in order to get these wire wraps on here, I want this board to not be able to move around so much, so I'm just going to put the screws back in it for now. Put my hands right in your face. Maybe we'll just put 2 in it. Okay, that's good enough to get all the wire rounds back on. Well, I forgot to hit start on the camera. Those 2 wire wraps are in, that resistor's in, that, negative and black and white are in. I have one more down here, the green one that goes to here, and I'm just going to wrap this one back with the pliers because I barely removed the coil on it, so I'm not going to strip it and start over from scratch. It'll be fine. I think. I hope. Let's see. See if I can twist it. I might end up having to strip this and start over. Well, I think we're okay. Yeah, that's on there good and tight. Okay. Let's fire it up on the dim bulb and see if we did anything, see if we broke anything. Okay, we've got it plugged in the dim bulb. Gonna turn it on. I already had it hooked up to the speaker, so I didn't have to change anything. Just had to plug it in. Volume is all the way down. Aux 1, 2, 3, I believe is FM. A little volume. We are pulling 14 watts. Looks good. No problem with dim bulb.
Started coming back on, he wasn't able to get extended like he was earlier.
So his longest drive was his first home run. To the top of the second level of the bleachers in left center went 466.
Wow, 4.
Okay. We're golden. Okay, here's what we replaced on the IF board. And, you know, I have a mental conundrum now because the same exact caps are on a few of the other boards, and I know they're going to be just as bad. So probably should just go ahead and replace those as well. What I have left to do is just clean it up a little bit more, and then replace all the lamps, and then clean up the case and put it back together. Okay, the silver lining on this board is that all of the connections are on the right side. So if I just take out the screws, then I can lay this board back this way and have good access to it. Now, this board, not so much. I'll have to figure out what I'm going to do there. This one, Wow, I put a screw way back in the back, so I'm gonna have to come through the top to get that screw out. Yeah, are there two back there? Yeah, there's two. There are two of them. So if I want to replace those electrolytics, I'm gonna have to get creative, which is fine. I have, let's see, 1, 2, 3, 4, 5, 6, 7 more on these two. But I didn't think about the back, so I have to flip it around and do the back. Okay, that board actually came out easily when you take the board out above it, because there's nothing in the way to get those screws out. So this one's crazy, dirty, sticky, so I swear someone spilled something in here. But I've tested these capacitors and they're all bad, so I'm just gonna pull them all out. All right, this one is a 4.7 microfarad and it's a little high. It's around 6. Let's see if we can get to the ESR. 6 ohms. Not great. I was looking straight ahead and I kept bumping something with the solder. And I'm like, what am I hitting? And you couldn't see, but there's a big terminal right here. And I couldn't see it because I was looking straight at it, straight down on it. So yeah, that was fun. We have one more on this board and it's right here. Okay. I once again picked the wrong hole. Okay. Now it's in the right spot. Now I gotta find the top one. I'm guessing it's that one. Right. She's out of there. Okay. So the negative's on the bottom side. Yep, that looks right. Okay. All right, the one I pulled out of there was a 2.2 microfarad. 2.2 microfarad at 50. So I'm going to swap in this WEMA film cap, which I can't even seem to flip over to the right side. Where are the numbers? Goodness gracious. Oh, this one doesn't have any on it. Yeah, it does, but they're on the end. See that? .2 microfarads, 63 volts. The leads on this film cap are super short, so I'm gonna have to, I had to tape it down where I wanted it so it wouldn't fall out. Where's that other one I took out accidentally? Right there. There we go. Okay, so I replaced the two caps in this board. One was electrolytic and the other I replaced with a film cap. I didn't unplug anything, so I'm just going to fire the dim bulb back up and make sure everything's still good. Okay, dim bulb's good.
Whether you love pulse-pounding water slides or relaxing in a wave pool, there's something for the entire family. This offer won't last long. Get your fork.
It won't last long. Okay, let's move on to the multiplex board. Okay, on the back side we have this board here, and there are a few bad caps, but there are a few good caps as well. But what concerns me more are some of the solder joints on the back. They're just not ideal, so Going to reflow a lot of these to make sure we have good connections, and then replace a few of these caps. Okay, the bigger capacitor on the bottom had a really high ESR, and it's a 16 volt 10 microfarad, so we're going to replace it with a 25 volt microfarad. 25 volt 10 microfarad, same size, just a higher voltage. Oh, don't put that in backwards. Okay, I was able to clean up this board and remove all the sugary soda residue and get all of these joints reflowed. And I think it looks good, so let's just fire it up and make sure it still works.
If you want to go to heaven, I want you to know all of the support PhD on this hump day comes from you, our listeners, of course, and the Brewing Archives and Museum presenting.
All right, that's good. Move on. Okay, the final board I'm going to address on this receiver There's this board here, the W15079, and I've already tested several of these capacitors, and these are extremely bad. I mean, they're still working, but they could work better. But if you look at the back here, we can see that there's some really bad solder joints here. This one is just sitting there. There's nothing in it at all. And there are a few more that need to be reflowed. So let's remove the caps that need to be replaced, and then I'll reflow some of these joints and we'll be done. This one is hard to tell. I think it says 0.47. Yeah, that makes sense. 0.47, 25 volts. So I'm going to put a film cap in there for that one. It's a Wingman cap. 0.47. Film cap. Non-polarized. Same deal here. No, this is 0.22. Okay. All right. Changing it up on me. Come on.
Are together. Each of your families, I think, has 7 boys.
Okay. Next. Okay, just to give you an idea of how I'm, deciding which capacitors to replace. First, I'll use the capacitor wizard if I can. And for example, this one I just replaced. Look here, I can show you that it shows bad, right? See that it's in the bad range, barely moves, not great. And then, just for grins, I'll take it out and test it in another tester. And let's just use this cheapy China tester, which is fine. If I can get it in there. Unknown or damaged part. Well, maybe it's just not making a good connection, and maybe it just is damaged. No. All right, let's try a different tester. $200 nanofarads. $66 ohms of ESR. All right, I think we have one more. I think. Does it still work?
Mean to say. Gentle.
Yep.
Loving.
I think the only one I'm going to replace, the final one that is bad is this other one. I think it's another 2.2 or a 4.7. This is a 4.7. So we're going to pull that one out of there. It should be these two here. Bueno. I'll just clean up this board and then put it back, and we'll be done with the interior for now. Okay, this board's clean and reflowed. So we're done with this board, and we'll just put it back and continue where we left off. Okay, this little lady has been turned on and operating for about 3 days now, and she's operating very, very cool to the touch. And we can even show the thermal activity with it just to prove that. Okay, here we go. It's about 100 degrees, 99 to 102, somewhere in there. On the heatsink, 103 maybe. Really cool. It's running very cool. You can see that the transformer is about 92 degrees. That's just whisper cool. Nothing else is really hot in here. You can look at the lamps. So maybe the lamps are warmer. That one's 182 degrees. Kind of warm. Anyway, so she's looking good, and all we really need to do is button her back up and put her pants on. Okay, one there. One here. One here. One here. And one here. And then it goes here. What is one? What is one? Come on, down there. Okay, I think that's good. Now we're just going to get that case cleaned up and then put it back on and reinstall the antenna. Okay, I was wrong. This does not go here. This is completely wrong, which is why it doesn't fit. I just had to screw it in the wrong holder spot. And this is the correct screw and washers. Okay. Now I polish these up. These go in the case. Hold the case on. We'll get to that in a minute. If I remember, these dummy plugs were in the ceramic side of Phono 1. I don't know. I'm going to put them in Mag 2. Magnetic cartridge Phono 2 because it's a good place for them because no one's ever going to use the second Phono stage. Okay, so here's the inside of the case cover, or the wooden cover. And it's just a little bit dusty. There's not a big deal. I'm going to try and clean out some of these dust bunnies and then see if I can get this tacked back down. I don't know how that came out of there. Might not be able to fix that. I don't know. We'll try. I don't want to tear anything up trying to fix that one piece, though. Yeah, that was easy. Let's see if I can pinch that in there a little bit better. There we go. Yeah, that's just dust, dirt. I'm just going to vacuum it out. Not a lot to vacuum, but I don't want it all over my room. Okay, that's good. Let's take a look at the other side. As you can see, it looks pretty good. I'm just going to use a little cleaner on it, and I'm going to use Murphy's. Let's do that. Man, this stuff smells good. Yuck. Getting better, but it's still yucky. Looking good though. Okay. Yeah. Look at that versus the side. Pretty big difference. This is clean. I'm gonna put some wax on it, but let's get the sides cleaned up first, and then we'll do that. Okay. We'll let that dry for a couple of minutes and then we'll put some wax on it. Time for wax. Okay, so what I'm going to use is this minimal bee wax. I like it and it works well, just straight up, bee wax. I'm going to get it on there and then wipe it off in a bit. Wipe the excess off. This old lady is thirsty. All right, I'm gonna give that a few minutes and then I'll come back and buff it out and polish it up a little bit. Okay, it's been 30 minutes and now I'm just gonna polish the case. Look at that goodness. Well, she's cleaning up nicely. I think it looks great. So let's get that reinstalled.
That wraps up this 3-part series on the Pioneer SX-990. It is working extremely well and looks beautiful. Thank you so much for watching. If you enjoy my videos, please like and subscribe. I hope you have a blessed day.